Section 2.2, operations with fractions. All my students always love fractions. It's their favorite. All right, well, for the next couple sections, we're actually going to be doing some review. Review of stuff you really should know already, but I find sometimes students do, sometimes they don't. We're going to deal with fractions in section 2.2, and then we're going to look at adding, subtracting, multiplying, and dividing numbers when some are positive, some are negative, so on and so forth. All right, so let's deal with fractions first. With fractions, we begin with simplify. So I'm going to give you a fraction like 12 over 18, and I'm going to ask you to simplify it. And I'm pretty sure all of you know what to do here. That's my guess. You look for something that they have in common. And what you do, technically, you recognize that 12 can be written as 2 times 6, and 18 can be written as 3 times 6, so you can reduce 6 top and bottom, and you end up with 2/3. Now, in reality, I don't really expect you to show that much work on a problem like this. If I gave you 15 over 21, I would expect that most of you can probably recognize that 15 and 21, I can reduce them both by 3. 15 divided by 3 is 5. 21 divided by 3 is 7. And so I would expect you to just do that in one step. If it helps you to write it out 2 times 6 and 3 times 6, that's called factoring. If it helps you to write it out factored, that's great. Go ahead and do it. It'll work just fine. All right, now let's talk about the confusion here. The confusion most students have is with adding fractions, subtracting fractions, versus multiplying and dividing fractions. Okay, so let's start with adding. Adding and subtracting are really the hard ones. And the key with adding and subtracting, I'm going to put a star next to this because it's so important. You, can't spell you correctly, you must have a common denominator. You cannot add or subtract fractions if the denominators are not the same. Not a choice, not an option. All right. So let's say we had 5/6 plus 3/4. Do they have the same denominator? Well, no, this one's got a denominator of 6, and this one's got a denominator of 4. They're not the same. I can't add them. So what I do is I need to make them have the same denominator. What we do is we find something called the least common multiple. And I think for 6 and 4, most of you can probably figure that out in your head. But again, if you don't remember how to do it, one way to do it is simply make a list. 6 times 1 is 6. 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. And you could continue. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. There's our common denominator. All right, so I'm going to write this problem over again. 5/6 plus 3/4. So I find for a lot of students it helps if the problem is written up and down. All right, so we need to get 12 on bottom. So in order to get a 12 on bottom, I got to multiply this fraction by 2. If I multiply the bottom by 2, I always have to multiply the top by 2. So that becomes 10 over 12. This one, I also need a 12 on bottom. To get a 12 on bottom, I'm going to multiply the bottom by 3, which means I've got to multiply the top by 3. So that becomes 9/12. We add them up, we get 19/12. Now, as far as I'm concerned, that's a perfectly acceptable answer. I don't mind if your answer is an improper fraction. This one's called improper because the top is bigger than the bottom. If you prefer mixed numbers and you remember how to do that, that's fine. You can write it as 1 7/12. I don't care. As far as I'm concerned, this is a perfectly acceptable answer, and I would most likely recommend you leave it that way, actually. All right, so let's try a couple more problems. How about 5/9 minus 2/7? Common denominator this time. Well, again, you could make a list till you find it. Again, I'm guessing most of you are actually pretty good at finding common denominators, so I'm not going to make the list. The common denominator this time happens to be 63. So once again, I'm going to write these up and down. 5/9 minus 2/7. And I need to write them both so that they have a denominator of 63. All right, so what do I need to multiply by? Well, the top fraction, 9 times 7 gives 63, so I got to multiply by 7 on bottom, which means I got to do 7 on top. 7 times 5 is 35. The one on bottom, I got to multiply 9 times 7 gives me 63, so 9 on top, that's 18. And now I'm ready to subtract. To subtract, the bottom stays the same, it's going to be 63. I subtract 35 minus 18 is 17. So there's my answer. Okay, so there's a brief review of adding and subtracting fractions, and that's really the hard one. Adding and subtracting is a hard one. You have to have a common denominator. For multiply and divide, it's actually quite a bit easier. So let's take a look at multiply and divide. Let's say I had 6/7 times 4/9. There are two ways to do this problem, so I'm going to do it twice. To multiply and divide, well, to multiply, the rule is you simply multiply tops, multiply bottoms. So I could take 6 times 4. 6 times 4 is 24. And then I could take 7 times 9, that's 63. 24 over 63. That's a good answer, but not quite the answer I want, because the fraction can now be reduced. 24 happens to be 8 times 3, and 63 happens to be 21 times 3, so I get 8 over 21. So there's one way to do the problem. Multiply tops, multiply bottoms, and then reduce. That's not the way I like to do it, though. So I'm going to do the same problem again. 6/7 times 4/9. What I like to do is reduce first, because then my numbers are smaller. I want to deal with small numbers when I can. And the rule on reducing when you're multiplying is you can reduce anything on top with anything on bottom. So what I'm looking at is I've got a 6 on top here and a 9 on bottom here. They have a 3 in common. I can cancel a 3 out. So I'm going to cancel a 3 out of each one. 6 is 2 times 3, and 9 is 3 times 3. And I don't see anything else that cancels. So now I multiply my tops, I get 8. Multiply my bottoms, I get 21. Personally, I think that's a lot easier. I think it's much, much easier to reduce first and make all your numbers small rather than to multiply first and then try to reduce with bigger numbers. All right, I'm going to try one more problem here. How about 5 over 21 times 18 over 25. Now, again, I personally, I don't want to deal with the big numbers. I don't really want to have to take 21 times 25 on bottom and then try to figure out how I'm going to reduce. I much rather reduce first. I see I have a 5 and a 25. Those can reduce to a 1 and a 5. And going the other way, I see I have an 18 and a 21. Those can both be canceled by 3. 18 is 6 times 3. 21 is 7 times 3. And now look how easy the arithmetic is. 1 times 6 is 6. 7 times 5 is 35, and I'm done. Now, I do look to reduce more, because sometimes I goof up when I'm reducing, and I don't reduce as much as I should beforehand. 6 over 35 doesn't reduce, though. All right, the last thing we have here is divide. 7/12 divided by 2/3. Here's the rule with divide. To divide, you flip and multiply. So you're going to have 7/12. You leave the first one alone, and you flip this one. You write it as 3/2. And then you're right back to where you were. I can reduce the 3 and the 12 to be 1 and 4. My answer is 7/8. Or let's say I write a problem this way. Let's say I write 3/4 divided by 5/8. The one on top stays the same, 3/4. You flip the one on bottom, 8/5. Again, I see a reduction, 1 and 2. That's 6/5. Okay, so I want to talk about two last things here quickly. One is, what do you do if you have a fraction and you just have a regular old number? Like let's say I have 5 plus 3/4. Well, what you do, if you have a regular old number and you have a fraction, you take the regular old number and you make it into a fraction. And this doesn't matter if you're multiplying or dividing or adding, subtracting, anytime you have a regular old number and a fraction, write the regular old number as a fraction. Write it as 5 over 1. Okay? I need my common denominator. My common denominator is 4. And I'm going to write this one as 20 over 4. I hope you agree that 20 over 4 is the same as 5 plus 3 over 4, so that's 23 over 4. And the last thing I want to talk about is dividing when you have a 0. And this is a common mistake that students make. If I asked you 8 divided by 2, I'm pretty sure you would tell me the answer is 4. And then I would ask you the question, why? And the answer I usually get from students in class is, well, because it just is. Well, really, that's not true. 8 divided by 2 equals question mark is the same as saying 2 times what will give 8. And students will immediately tell me, oh yeah, that's right. The answer is 4. So what if I give you 8 divided by 0? Well, 8 divided by 0 is question mark. A lot of students are going to tell me the answer is 0. And I'll tell you right now, the answer is not 0. So I'll say, this is the same as 0 times what gives me the answer 8. And the answer is nothing. So this fraction, 8 divided by 0, this is undefined. You can't do it. As opposed to 0 divided by 8, 0 divided by 8 is 0. So the rule you need to remember is, it's okay to have 0 on top. 0 on top, 0 divided by 8 is going to be 0, that's okay. But you can never have 0 on bottom. Anytime you have a fraction, and you have 0 on bottom, your answer is undefined. It doesn't matter what the top is. Some students will argue that 0 over 0 should be 0, and it's not. 0 over 0 is also undefined. So watch out for that. You can never have 0 on bottom. Anytime you have 0 on bottom, your answer is going to be, that's undefined.